Okay, today we are going to continue with electrolysis. Just have a quick recap and then we're going to continue with the sheet that we were working on last Monday. So electrolysis, again, that word electrolysis, you're using electricity to split something up. Lysis just means split. And we use electrolysis to split up ionic compounds. Ionic compounds are made of metals and non-metals. So when you split them up, you get a metal and you get a non-metal. Electrolysis, so the electro bit is for the electricity. You're going to use electricity to split it up. You're going to do that in the form of a battery. So you connect the positive part of a battery to what's called an electrode and the negative part of a battery to an electrode. The positive part of the battery is panic, so positive is anode, negative is cathode. So you connect the positive part of the battery to an electrode. Electrode is just something that can conduct electricity, usually a metal. You connect the negative part of a battery to something that conducts electricity. You put these electrodes into a beaker and you place your ionic compound in the beaker. Your ionic compound has got to be liquid because ionic compounds do not conduct electricity when they are solid. Okay, so they have to be liquid because the ions have to be able to move. So ions need to move. If your ionic compound is a solid, the ions can't move and they can't conduct electricity, and this isn't going to work. So your ionic compound is going to be in liquid form. There's two ways to put it into liquid form. You can either melt it, and if you melt it, we call it molten, or you can dissolve it, and we call it aqueous or in solution. So let's say we've got sodium chloride as our ionic compound. It's an ionic compound because it's got a metal, sodium, and a non-metal, chlorine. And when I split it up, I'm going to split it up into ions. Okay, so all ionic compounds can be split into ions originally. So sodium, if I look at my periodic table, I see sodium is in group 1. If it's in group 1, it's got a +1 charge. Chlorine is over here in group 7. If it's in group 7, it's got a -1 charge. So the two ions that are present are Na+1 and Cl-1. So when I turn on my battery and my electrode becomes positive and my other electrode becomes negative, what's going to happen is that all of my positive sodium ions are going, all of my positive sodium ions are going to go to my negative cathode. So they're all going to come over here. And then all of my negative chloride ions are going to come to my positive anode. Because opposites attract, the positive metal will go to the negative cathode and the negative non-metal will go to the positive anode. So it's always opposite charges attracting. So I've used electricity to split up an ionic compound. My ionic compound is sodium chloride. So I'm splitting sodium chloride into sodium and into chlorine. Okay, your positive ions go to the cathode, your negative ions go to the cathode, and these charges I'm just getting from the groups of the periodic table. That's if it's molten, okay? Things are a little bit different if you dissolve it in water, which we're going to look at now. So if I had exactly the same setup, so I've got my positive electrode and I've got my negative electrode, but instead of melting sodium chloride, I'm going to dissolve sodium chloride in water, and it does make a difference. So it has to be liquid, but I can melt it or dissolve it. Up here, I've melted it, so I've only got sodium chloride, and then here, I'm going to dissolve it in water. So this one here should have been molten, and down here, I've got sodium chloride, but it's aqueous. And if it's aqueous, it means I've dissolved it in water. So if we look at the ions we've got present now, it's still sodium chloride, so I have the same ions present. I've got Na plus and I've got Cl minus. But if it's aqueous and you've dissolved it in water, then you also have the ions from the H2O itself, and H2O will split up into H plus and OH minus. So instead of just having one positive ion like we had up here, we've now got two positive ions. We've got Na plus and we've got H plus, and both of them will go to the negative cathode. Similarly, we've got two negative ions. We've got a negative chloride ion and a negative OH minus ion, and they'll both go to the positive anode. Only one product is going to form at each electrode, and you need to know which one. So if we start at the cathode, we've got two choices. We've got sodium and we've got hydrogen. There is a rule, and the rule states that the least reactive will always be the one to form. So least reactive forms as your product. Okay, I've given you that list of the the reactivity series of metals. Sodium's on that list. It's the second from the top. It's very, very reactive. And hydrogen's also on that list, but much closer to the bottom. Okay, so least reactive always forms. Hydrogen is less reactive than sodium. So hydrogen is going to form. And because hydrogen is forming, hydrogen is a gas, you are going to see bubbles at your cathode because hydrogen is forming. All right, least reactive always forms. And that's always, always going to be hydrogen, unless the metal is copper. Copper is the only metal that's less reactive than hydrogen. All of the other metals that you're going to come across are more reactive than hydrogen, and hydrogen is going to be the product. So hydrogen gas is going to be your product. At the anode, you've got two choices. You've got chlorine and you've also got OH minus. The rule at the anode is that the halogen, which is group 7, always, always forms if you've got a halogen present. So the halogen, group 7, is chlorine. Chlorine is going to form. Chlorine is also a gas at room temperature, so you are also going to see bubbles at the anode. Okay, so you can see here, our ionic compound was the same in each case. I had sodium chloride both times, but when it was molten, my products were chlorine and sodium, and when it was dissolved in water, my products became chlorine and hydrogen. So dissolving it in water changed my product at the cathode. I'm no longer getting sodium, I am now getting hydrogen gas. So that's something to consider when you're using this technique. If it was sodium that you were trying to get, there is no point dissolving it in water. You would have to melt it, or you're not going to get sodium. You're going to get hydrogen instead. So depending on how you've made it liquid, if you've melted it or dissolved it, it may affect the product that you are getting. Okay. We're now going to go to that. I gave you a sheet on Monday that had loads and loads of these as examples, because this is a really, really common exam question where they just ask you to predict the products. I'm going to go into a separate video, because this one's getting a little bit long, and start going through these with you. So if you have this sheet with you and you've already got started and you know what to do, then just carry on. If you haven't got started and you don't know what to do, then look at my next video. I'm going to do the first few examples for you.